In the last class we were looking at just the graphs and we didn't talk about the equations. Of course, some of you know the equations already. So what we'll have a look at is what equations we can make. Alright, so just to clarify some terms, first write down the name of the lesson. Equations of motion. Okay, so clarify some terms. Uniformly accelerated linear motion. Let's look at each word here. So, I think you might know some of these words. Of course, motion means movement, of course. Linear, not quite. I mean, it could, depends on the context. In this context, what does linear mean? Yeah? Straight, yeah. In a straight line. Accelerated, so it has an acceleration. And uniformly, constant what?
Velocity.
Not quite acceleration. So uniformly accelerated linear motion is motion which is in a straight line, that's the linear part, has a constant acceleration, that's the uniformly accelerated part. And it's very, very common in physics. You know, it's like one of the most common physics situations. So just to be good, just for good practice of vocabulary, I'd like you to write down this uniformly accelerated linear motion. And you don't have to write the definition exactly like this. This is more about building your vocabulary. Okay, so uniformly accelerated linear motion. Okay. Continue. Did you write this down? Okay. Moving on. So, these types of graphs produce straight lines. So, whenever we have this situation in physics, if we were to graph it, we get a perfect straight line graph here. So, there's my time, seconds, velocity, meters per second. Uniformly accelerated linear motion always makes graphs like this. Not this. We don't call this uniform acceleration. Why not? Yeah, the acceleration has changed, for example, from being a positive to a negative. So when we say uniform acceleration, the graph only can be this, a straight line, no more. Okay, so we'll call this part U, and this one here V, and here T. And let's see what equations we can make. Now before I even start with this graph, let's just go back for a moment to our triangle. On the top, distance, speed, time. Okay? So, if we're using UVATS, I could say distance, what letter would that be? S with care though, equals speed multiplied by time. Now here comes the problem. This is only for constant acceleration, but here the acceleration is not constant. The speed has changed from U to V. So what do I put here? Do I put U, or do I put V, or something else?
V minus U.
Maybe. Not V minus U. Good idea though. U minus V.
It is V minus U.
Oh, trust me, it's not.
V minus U over V.
Getting closer, but not this.
V minus U.
You want it in terms of U and V?
Well, it doesn't have to be, whatever you have.
Divided by 2, yeah.
Because if we have two speeds and we need to use only one speed, we should use the average of the two speeds. Hence the u plus v over 2. So this, in fact, is our first equation for u, v, a, t, and s. And I'll call this equation 0. This is our first equation.
So what does the t stand for?
Time.
So okay, so we find the speed and then we just multiply it by time, which is basically what we do.
Yes, yeah. So there's a connection between the two here. There's a connection between this formula and this triangle. Okay, so this is our first equation, so you want to write this down. I'm calling this equation 0 because it's not really a new equation, really. I'm sure you did. If you even had a halfway good physics teacher, I'm sure you did. I'm at least half good, so you'll do them with me.
Oh, you're good.
I know, don't say that yet. No, it's too early to say that.
Oh,
wait till
after midterm.
Exactly, wait till you get your results. Okay, we continue? Yep. So that's our first equation. Right. Let's see what other equations we can build. So I think we'll go with the acceleration next. The acceleration is the slope. Here is the point 0u, and here? What's this point? What is it?
V. T. No, it's TV.
TV. So the acceleration is v minus u over t minus 0, or t. So we get a equals v minus u over t. So we get at equals v minus u. So now we have our next equation. V equals u plus at. And if you're thinking, hey, I've seen that before, you're probably right. This we'll call equation 1, our second equation.
U plus
at.
AT.
Okay. We got this? Next equation. Let's have a look at the area. So what does the area represent?
Distance.
The distance. So S equals, what's this area?
U times T.
U times T, or T times U. And this area is a triangle, so it's a half times T, times V minus U. Yeah. Now before I continue, these proofs could be on the exam. There's not many proofs you need for the exam in physics, and I'll alert you when there is a proof that you could need for the exam. And this is one of the proofs listed in the syllabus that you might need for the exam, the proof of these formulas. Okay, so when you're making these notes, make sure you can read them. So we'll put this one in here. So we'll get S equals ut plus a half t, u plus at minus u, because I've replaced the v here. Can you see that with this one? What happens here? What happens here? Yeah, because what happens?
U and U
They cancel. So you're left with S equals ut plus a half at squared.
So which one is the third?
This is the technique. Looks familiar again?
Yeah, it does. Well, the procedure. Never seen that.
You haven't seen the proof before?
No.
No, okay. One more equation to go. Let me think for a second. Right. So here, let me just take this for a moment. You see this one here? And just write it over here. A equals V minus U over T. So T equals V minus U over A. I'm taking that and I'll put it in here. So now I get S equals U plus V over 2 times V minus U over A. So S equals, multiplying this out, UV minus U squared plus V squared minus UV all over 2A. So I get 2AS equals minus U squared plus V squared, because again we'll have some cancelling. So I'll get V squared equals U squared plus 2AS. Equation, fourth equation, number 3.
So we start
Counting at 0.
with a 0.
That's the first equation, equation 0. In physics, we start, if the first rule is something very basic and not new to the theory, often we start counting it at 0, if that makes sense. So because really that equation has existed in the triangle when you've done it before in like middle school, it's not actually new to this chapter, so this is why we call it 0. And then we'll start 1, 2, 3 are the new ones. So again, I'll remind you, the proof of these 4 equations is something that could be on the exam. This is the easiest way to prove them. Okay, continue. Yep. So, these proofs are on the exam. To summarize, S equals U plus V over 2T, V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. To solve any problem, we require to know at least 3 of the 5. U, V, A, T, S. We must know 3. Any 3. If we do not know 3, we cannot use these equations. So U, V, A, T, S, we need to know at least 3. These problems are often called SUVAT problems, but I've never gotten into the habit of calling them this. So, because my teachers always called them UVATS problems, I've continued to call them UVATS problems, but you can call them SUVAT problems. So yes, I'm afraid this has stuck with me forever, UVATS, that's what I'll call them. But I actually do prefer SUVAT because it's one word. Whatever, you call them SUVAT or UVATS. What did you call them back home? Nothing. Oh, that's so long. They're also known as kinematic equations of motion. Yeah, you might want to write that down as the name of the equations. Kinematic equations of motion, rather. So you'll need this in red here. Okie doke. Right, so let's have a look at some examples of using these formulas. So like I say to the students, if your English is a bit weak, maybe you want to write the question down, or you can draw a picture with the information in it, or you can just write down the information. I'll do this question. All I want you to do is to write the question down. Like I said, you can write everything down, or just draw a picture, or write down the key information, whichever works best for you, okay? But you don't have to do it right now. I'm going to do it in 1 minute, so just make note of this, please. First example. Oh, Lee. Why do you like writing at... Oh, okay, thanks. You make me feel better. Who are we missing?
Omar.
Who's that? I've already forgotten them.
Glasses.
Glasses.
From Saudi Arabia.
Saudi Arabia.
He came late.
Came late. How many classes have you been in?
1 week.
Yeah, I haven't been teaching them for a week and I've already forgotten them. Omar with the glasses.
Cousin was past friend.
This is terrible. Hang on, it'll come to me in a second. You haven't got like his
maroon coloured jumper.
No, not helping. You haven't got like his picture on your phone, have you? Goodness, what does he look like? Omar, glasses, moustache.
Well, the moustache is not that thick, so don't make a picture with a moustache.
He's always smiling. Always smiling. Short haircut.
You know him as well.
When we move the 2AS to the other side.
Doesn't change the sign if it's moving from denominator to numerator. You're thinking of when it moves across the equal sign.
2A. Yeah, across the equal sign.
What does he sound like?
Oh, he's very squeaky. Like,
No.
he is kind of squeaky.
He's not squeaky.
He's very low. His voice is low.
Do you realise those two are completely opposites?
Yeah.
Voice is very low and squeaky. It's like,
No,
As in
not
quiet.
squeaky.
It is kind of squeaky, like.
I'm going to see him tomorrow and I'm going to be like, oh yeah, Omar, forgot about you. I can't picture him, it's so annoying. Alright, I'll find out tomorrow, I guess.
Oh, he needed a Moodle account. No.
They owned it.
Like recently.
Now I remember, yes, I remember. Yes, he is always happy. Yes.
He said that.
Yeah, yes, he seems like a happy fellow.
He's always smiling.
Yeah. And I also remember he was friends with Ali Rifai.
His friend was one of the older students, yeah.
Yes. Now when he watches this video, he's going to discover that his teacher has forgotten about him. So, sorry Omar.
I didn't get this.
Alright, is this the proof?
Yeah, the
proof. We all like Omar, he's the best.
Yeah,
Alright, we'll bring... Which part?
This lecture.
Oh no, you see, what you're missing is there was... I think you missed a minus sign when you were writing this down. This is probably the problem. So there's actually a minus u squared here.
Minus u squared?
Yeah, and what happens is when it comes over here, it became a plus.
Okay, and then...
So it's like... v squared.
Yeah.
Okay, let's have a look at this one. So, what information do I give you in the question then?
U, V, and T.
Oh,
There you go, bicycle. Right, so starts at rest.
Yeah.
So that means the U is 0 meters per second. And then she finishes here at a speed of 9 meters per second. And what else we told? The time it took to get from here to here was 6 seconds. So UVATS 0, 9, 6. And what do we want first? We want the S. So which formula could I use?
0 plus 9.
Yeah, which of the 4 formulas?
0 plus.
Yeah, what's the letters? S equals? Yeah. So S equals U plus V over 2 times T. So that would be 0 plus 9 over 2 times 6, which is 18 meters. Yeah. And then the second part, what do I want? The acceleration. What formula could I use for that? The V equals, I think, yeah? I could say V equals U plus AT. What's wrong?
27, not 18.
Agreed. I agree with you. 27 is right. 27. It's been a long day. Okay, V is 9, U is 0, A is what we want, and... Is that done?
No.
Are you sure? It really sounded like it. U is 0, A is A, and T is 6. So that's a 6A. And what's the A here? Yeah, 9 over 6, which is 1.5 meters per second squared. So this was the first part, and this was the second part. Okay, so a basic question to start with. Yeah. You're writing that down, okay. Did you write this down? Yeah. You studied physics before? Yeah. Kind of. What's kind of?
I studied mechanics.
Yeah.
In AS,
They have mechanics, yeah.
Mechanics and math and C12, they call it core 12.
Core 12?
Yeah.
C1, C2?
Yeah, that's what.
Yeah, okay. Okay. The mechanics one, yeah. It has the UVATS in it. Yeah, and lots of other stuff too. Yeah, that's good. But not anything like electricity or... No. Alright, next. Okay, so now I'll give you this one to try, and I'll do the answer. But before you try, wait, listen. Note, you need to convert this into meters per second. Okay? It's up to you. For people who need to practice their English, I encourage them to write it down. But if your English is good, you can just write down the key information. It's up to you. It's up to you. I mean, as long as your notes are clear and you know which lesson this is, you could always get it from the video later.
True.
Yeah. So. Got this finished? Humor me. Do it anyways.
I was trying to remember. There was constant. We used to use a fraction to convert.
No, I hate all this stuff. It makes me so sad. No, do it the way I showed you, the way I like it.
Yeah, I know.
I know this fraction, and you multiply it or you divide it. Yeah, no, this makes teachers sad. Don't do it this way. I know, but it's bad habit. It's a bad habit. So I'm looking for the A firstly. Anybody have an answer yet? Any answers yet?
T is 6 seconds.
Could be. Did you get the same?
Yeah.
Right. Let's have a look. So the Road Safety Authority says that a car which is travelling on the motorway, there's my car, at 120 kilometers per hour, it will need 100 meters of motorway before it can stop. So if the car was braking, and look, we'll add in dramatic brake lines, it'll take 100 meters for it to stop. So here we actually know the U, V and S. We have the U, we have the V and the S. But we need to convert. Well, firstly, that's 100. That's 0. 120 kilometers per hour equals 120,000 meters over 3,600 seconds.
That's 3.3333.
Okie dokes. That sounds about right. Yep. 33.33 meters per second. So if I want the, which is it? The A, which formula could I use?
A to B squared minus U squared.
Yeah, I could say V squared equals U squared plus 2AS. 0 equals 33.33 squared plus 200A. Because it's 2 times S times A. So this works out to be minus 5.56 meters per second squared. Now why is it minus?
Because it's decelerating.
Decelerating, yeah. And the last part is, how can I get the time? What would be the easiest one to use for the time? Yeah. V equals U plus AT. 0 equals 33.33 minus 5.56 T. So T equals 6 seconds. Okay, that was okay, wasn't it? Especially if you've done this stuff before. Continue. Yes? Oh yes, you need an appointment, was it? That was it, accommodation, yeah, so you can go, yeah. So where did Omar go? Visa, okay.
Question.
Yes.
Our appointment is for the ID card or is it for the visa card? I don't know. This is not a card.
I don't know. Why, when's your appointment?
3rd of February.
Okay. Do you have your GNIB card?
No.
So it's probably for the card then, because that's one of the first things they want to give you.
So the card
What
has
does
nothing
the
to do with
card
the visa.
allow us to do?
Like an ID.
Kinda, it's like proof that you're a student here.
Like visa, you have 30 days to sit in the island,
Yeah.
you know?
No, but his appointment is probably to give you the card.
Yeah.
Are we allowed to re-enter Ireland with this card?
Oh, it depends on your country. Depends on your country. So there's a list on Moodle of which countries need the re-entry visa and which ones don't.
And how do we get the re-entry visa?
Make an appointment in GNIB.
Another one.
Yeah.
Can we make it before we go for our first appointment?
Goodness, I don't know. I would have thought usually it's the first you get your card, then you get your re-entry visa. I don't know if it's...
No, I mean
But
like...
the card itself allows, like it's a visa, right? It allows you to stay in the country.
Yeah, like there'll be a date on the card that says when you need to get out.
Because my visit visa expires in like 10 days.
And when's your appointment?
10th of March.
So you're going to be illegal for like what?
Pretty much, yeah.
Well, that's okay because you've notified them and this is the appointment time that they've given you, so there's nothing you can do about it. So like, you know, if there's a problem, you say, well, you know, what can I do? Or I gave them my information, this is the time they gave me, you know. I know that, yeah, should be okay. Just don't get up to any trouble before then, you know. Don't give them a reason to kick you out, you know. Stay good. Yeah?
I try.
Try, yeah. No, I know, it's difficult, but try your best. Okay, next one. Right, here's another one now. Again, I'll let you try it first and then I'll do it. So, a ball is dropped from the top of a building. From rest, the building is 25 meters high and it takes that much time for the ball to hit the ground. Okay, so again, try this one now, similar to the last one.
G.
Not necessarily. Maybe I put in resistance in the question.
No, you didn't.
You don't know what way I think.
It has to be because you
And
only
anyway,
see-
who said the school building was on Earth?
No. Okay.
It never said this was a human school building. Oh.
U is initial velocity, right?
I discovered yesterday the principal was talking to me and I have the most classes, more than any other teacher. So if it ever seems I'm tired, just give me a break.
Ask for more money.
Unfortunately, it doesn't work like that. You do what you're told to do and that's it.
Resign. Because they give you so much classes, that means they're lacking teachers. So if you threaten them that you will resign, they will increase your salary.
Don't know. I don't think they need me that badly.
If he
They need you that badly
resigns,
to have so many
if he
classes.
resigns, you do know that we are done. Like, I don't
Yeah,
know.
you don't know, you could get somebody now that doesn't know the difference between a U and a V, like, Okay, how are we doing with this one? Did we get the first part yet? Nearly.
Yeah.
Did you get the first part?
No.
Yeah, and the second part?
No.
Yeah, okay. Let me draw it anyway. So, now part of the reason I wanted to do this question is because I wanted to show you how I like to do the science. What I mean here is, what did I say the height of the building was?
25.
25 meters. And the time? 2.26. Right, now, UVATS, what's the U? 0. V,
No.
we don't know. A, we don't know. T, 2.26. And F?
25.
Now this is what I prefer you to do. I would prefer you to say it's minus 25. Because if we're starting here, remember I said down should be negative. So I would prefer this if you put it as minus 25. So what formula can I use to get the A?
The basic one, the 0.
S equals UT plus a half AT squared? S equals...
V plus V over 2.
Yeah, that's what it is.
But we don't know the V.
But then we can find
You
it.
know the
Yeah, you
but-
can find the V and then...
No. We wanted the... What did I want first? The A, wasn't it?
Yeah.
Yeah, so let's try and get the A directly. What else could we use? Could we use S equals UT? Yeah.
You can.
Not really, it's displacement. Yeah, which is a position. It has a positive and a negative. Yeah.
Well, we can use...
Remember my warning in the last class? Yeah. So S equals maybe, yeah?
UT.
S equals UT plus a half AT squared. So S equals UT plus a half A T squared. Yeah. So if I multiply by 2, I get minus 50 equals A times 2.26 squared. So I get A is minus 50 over 2.26 squared. Minus 9.8, you say, meters per second squared. Interesting. And now, what do I want? Probably the V, is it?
No.
So what can give me the V? V equals, I'll just write it here, U plus AT. But what's the U? It's just 0. So it's A times T, which is minus 22.1 meters per second. Now why is the V a minus?
Because it's
Going down. But I asked you for how fast it's going, and fast means the word speed. Do you know? So if I ever ask how fast something is, that means it's speed. So I don't care about the minus. So the speed will be 22.1 meters per second. So this is the answer.
But would it be a problem if we put the negative sign?
I think I'll let that slide. Okay, can I continue? Okay. Right, so here's a picture of Mary. She's dropping a ball off a cliff and she notes that the speed increases. At the beginning it's at rest. 1 second later it's going about 10 meters per second. Another second later it's going 20. Another second later it's going 30. So what's happening as it falls? Accelerating. When a ball is dropped from rest, it will increase its speed by about 10 meters per second each second. That is, the acceleration is roughly 10. So we have this concept called the acceleration due to gravity. Anything that's falling is accelerating, and the acceleration is actually a number that we know, and we call this number g, and the value of g is 9.81. So when anything is falling, it's gaining 9.81 meters per second every second. This is the value of acceleration when something is falling to earth when you drop a ball, for example. And you can take this as a fact in questions that involve things being dropped. So if the question doesn't provide the acceleration, it's probably because it's being dropped, and this is the acceleration. So G is 9.81. That's the value of G in this course. Maybe in your course you use 9.8 or even 10. I don't know if you remember. Does anyone remember what they used?
9.81 and 10.
10? Who said 10? You said? Yeah. Anyone use 9.8?
9.88.
And 10?
9.81.
88. Less.
Or 88.
Yeah.
I can actually tell you the exact value here if you're wondering, because it's on this Casio calculator as constant number. Where's it gone?
It's 35.
35. Good man. 35. Yeah, 9.80665. So actually maybe this is a good time to show you how to use this Casio calculator. So on the lid there's a list of 40 constants. Constants built into the calculator that you can use. So if you type in, can everybody press Shift 7, I think it is, and on the screen it asks you which constant you want. So for example, if you want G, you then press 35 and equal, and you get the G value.
You don't have to press equal.
No, actually it does it after a second, doesn't it? Yeah. Can you see? Do you have this one? You have this one. That's so old. How do you feel about buying a new calculator? The one recommended for the course is Casio 991. You have that one?
No, I have the name.
Oh, okay, good. All right. Because I was going to ask you, if you have that one, why did you take that one?
You can find it in a week, we'll pay for it.
Don't look for it, just order it.
Amazon. You got yours in?
Yeah, we got it yesterday. It was supposed to come in on Thursday.
Oh, good. It came in sooner then.
Yeah.
Good. Okay, let's continue. Right. This one now, again a bit trickier, but it's the last one, but it's a tricky one. So I'd be very interested to see how you do it, okay? A ball is thrown vertically up at a speed of 50 from a girl's hand, and her hand is 1 meter off the ground. So it's like somebody standing here, and you hold the ball like here, and then you throw it up, but you let it come back down to the ground, not to your hand. So it goes up and comes down to the ground. That's what's happening in this story. She throws it at 50 meters per second. So the first question is, what is the maximum height? Now the hint, which you probably know already, when something is being thrown up in the air, when it's at its highest point, what is it? Its speed is 0 at its highest point, and then it falls back down. So you know how to get the A, I think. Let's see how you do. The B might start being a bit tricky. When does it hit the ground? So try this one, then I'll do it. Let's see how you do with this one.
Till what time do they stay in the office?
Whose office?
Sophia?
4:30.
4:30. Do you need to get something urgently?
I wanted to ask about the bank accounts.
Oh,
I
they
might
told
know.
us- They
What do you
actually told us, you're asking about the card, yeah?
Yeah, when are we supposed to check?
You're supposed to call and ask if your account is ready. Currently.
Call. Oh,
They gave you a booklet, yeah? And
Yeah.
it had her contact details.
okay.
You call
And
them.
you collect the card, is it?
Yeah. See if your account is activated and then collect the card.
KBC?
AIB.
AIB.
I think.
No, it's
Is it
KBC.
Yeah, I think so.
It's important to know the name of your bank.
KBC.
They'll be holding a lot of money for you. Yeah.
Yeah.
Is it KBC or AIB?
Well, let me see. I have to think.
It doesn't work.
It
I
doesn't
tried it on a trolley, it didn't work.
really.
Try it on what?
They
It's
told us this
KBC.
is for the trolleys. And then to unlock the trolley.
Yeah.
I put it in and I pushed it, it doesn't go in.
Maybe it was just that trolley.
No, I tried a different trolleys.
Maybe it's you.
Possible.
Possible.
But yeah, they work till 5. We was meant to call them today, actually.
I'd be happy to take it off you if you don't want the key.
I gave it to someone else. I
Ah, right.
to open the trolleys. But apparently it wasn't opening the trolley.
Okay, alright. Okay, try this one now.
So we can use a constant for this.
Yes, you can, yep. Who's that going to be?
Me.
Hi.
Lorraine, now you're too. We're wondering who this is going to be.
Can I give
Chemistry notes, no
chemical
problem.
notes to along there? They're slightly knuckly assembled, but I did cut my finger with a knife stupidly yesterday. So I'm not going to be able to do this. So you have to put it
Was it for? I think you
Oh, you use them as well, of course. Pardon me?
No, you can do it yourself.
Okay.
Yeah. You'll figure it out.
If you come after your class to me, I'm in D117 and I'll give you some notes. How about that? Yes, D117. Thanks.
Okay, have we got the first part finished now? Got the first part finished? First part finished? Part A? Part A? What's that mean? Finished, not finished?
No.
How big is the A4?
big enough, because 50 is quite fast. So what number did you get?
127.46.
That sounds familiar. Let's have a look. Okay. Maybe I'll do it bit by bit. So first I'll do the A part and then see if we've got the B part finished. So the A part. So the ball gets thrown up to maximum height. So it's a UVATS. U is 50. V 0. A minus 9.81. T we don't know, and S is what we want. So what formula could I use?
Is it minus 9?
Yeah.
But it's going up, is it?
Yeah, but the Earth is pulling down, so the gravity is downwards. What formula? B squared, I think, equals U squared plus 2AS. Because then I can say 0 equals 50 squared, and then 2 times A. That'll be minus, let me type it in, 19.62 S. I got S is 127 meters. Is that the answer? It is not the answer.
Yeah, that's what I got.
What?
It's not the answer.
What's what?
127 is not the answer.
It's not the answer for what?
The maximum height.
It's 128,
Yeah.
because she's holding it 1 meter.
The 127 is from here to here. Not including the 1 meter at the start. So that was a little of a trick. Okay, the B part. Did anyone get the B part yet?
I did.
Yeah, okay, we have one. Anyone else get the B part? Not yet? No? Okay. Well, we have a look at the B part now, which was, what was the B part? The time? How long until the ball hits the ground? So we want the time to go from here up and down to here. U, V, A, T, S. Okay, what's the U? 50.
Oh.
The V?
0.
Well, we don't know because it was 0 up here, but we don't know what it's down here.
It's better to split it.
No, it's not. It's definitely not.
Because...
No, trust me. Definitely not.
Okay, do we need
It
to...
will be more than 50 on the way down.
Yes, it'll be more than 50 here.
So we just calculate from the point it starts decelerating.
No, from here to here.
Oh.
U is 50 here. V, we don't know.
What about initially?
50 here. From our hand. At the beginning.
When I thought it's 0, isn't it? Because it's in our hand.
No, we won't. No. It says it starts at 50. Okay.
Okay.
Immediately after the ball is released from our hand, it's 50. How's that for you?
Yeah.
Okay. The V we don't know. The A
9.8.
Minus 9.81. The T is what we want, and the S minus 1. Because it would be 1 meter below where it started, yeah. So if we use the formula S equals UT plus a half AT squared, S equals UT plus a half AT squared. I'm going to take all of this to the left. So I'll get 4.905 T squared minus 50t minus 1 equals 0. Now, this equation is called the quadratic, and you haven't learned how to solve that in maths class yet. You'll learn how to do that this week. For the moment, we can cheat and use mode 53 on our calculator. Yeah?
Which equation did you use?
Oh, sorry, I didn't write it down. S equals UT plus a half AT squared. If you type mode 53, what do you get on your screen? Mode 53, and you're prompted for A, B, and C. Can you see that?
Yeah.
That means if you type in these 3 numbers, the calculator will give you the answer for t. 4.905 equal, minus 50 equal, minus 1 equal, equal. So I got an answer of 10.2 and minus 0.02. So which is the right answer here? Obviously the 10.2. So the answer is the time is 10.2 seconds. Now we'll learn how to solve this properly in maths class, but just for today we'll use this mode on our calculator.
Can we use it in the exam?
No.
How would they know?
Why
I have my ways.
why did you divide 9.81 by 2?
Didn't have to. It's just nice to have them all as decimals. Oh, this is in the formula, a half AT squared. Yeah. I just put it in the decimal.
When the gold top
Yeah.
going plus,
Yeah.
and when the ball coming down, it's going
Minus, correct, yeah.
Okay, the U is not.
The U is plus because at the beginning it's going up.
Okay, after that
We haven't calculated the V yet. The V should be minus, which I think the next one's probably the V. No, the next one is the S. Then the next one. Will we get the V? No, we won't. I didn't ask what the V is, but if you calculate it, will be minus. Yeah. Because here, Nader, at the end it's going down. So this will be negative. Okay, part C now. How far does the ball travel? No special calculations there.
255.
Yeah, 127 plus 127 plus 1, isn't it? 255? Okay. D. What is the... Oh, no, there's going later. How fast is it going when it hits the ground? So that's V equals U plus AT, which is 50 minus 9.81 times T, which is minus 50.06 meters per second. So that's how fast it's going when it hits the ground. And finally, E. The last part is, what is the average speed? Now, I don't remember if I said it exactly, but does anyone know the formula for average speed? See, again, it's a middle school type of formula.
Total distance of the time taken.
Yeah, total distance over time taken. So what's the total distance here? 255 over 10.2. 25.
How do we go back to the normal mode?
Oh, mode 1. Okay. Got that? I gave a question like this in the end semester exam, and a lot of students, I don't know why, it drives me crazy, but a lot of students, they do this part in two halves. They go from here to here, and then here to here.
Gives you the same answer.
I know, but it's so much longer. You can just do it in one go, like this. Anyways. Okay, did you write that down? Yep, okay, so. Let's see. Right, I think what we'll do is we'll leave the last few minutes for time for you to try the homework, which is on Moodle. If you want, you can take a picture of the screen, but I think it's easier to read it on Moodle. And you can work on these for the next 10 minutes, and then whatever you don't have finished, that will be for homework then, okay? But you might get nearly all of them finished, like 1, 2, and 3 you should be finished before going home. No, actually 1, 2, 3, 4. 1, 2, 3, 4 I expect you to get finished in about 10 minutes. 5 might require more thinking.
physics homework.
Yeah, but you only have this homework, so.
We should convert it into meters if the distance is in meters, yeah?
Yeah.
The kinetics, the force we get, they ask us in the test like how you can get one to it.
Yeah, they can ask you for the proof, to prove it, like what I did at the start. Yes, you could.
Yeah.
They can. It's not likely, but they can. Can I close the slides? Do you have this on your phone, Nader? Yeah. You taking a picture?
I have it in movie already.
Okay.